In today's show, we discuss the Big Bang. Did it happen? And was there anything before it?
And now, the TNT Talk Show, daring to go where other podcasts fear to tread.
Hello, I'm Tony Fasula and I share the stage with my esteemed friend and colleague, Tayo Boya. Tayo, hello my friend once again. I hope you're keeping safe and well.
Yeah. What the hell, Tony? What you gonna do, eh?
Come on, be upbeat. I'm all energized. I've come back from my trip away and I've come to see your smiling face and I'm all...
That was a mistake.
Come on, say hi to our audience. Come on, be upbeat.
Yeah, hello, audience, whatever the hell. What the hell? What are you gonna do? Anyway, so I think I've got one for you. I got something for you here,
Oh,
Tony, just
God.
to put a smile on your face. Although this might cause you some physical pain, but you're man enough, I think, to take it.
Okay.
Yeah, you ready?
Apprehension sinking in. Come on.
You're man enough. You can take it. What do you call a cheap circumcision?
I don't know whether to answer this. No, I don't know. I'll let you answer.
A rip-off.
Oh.
Oops, that might hurt a bit. Oh, ouch.
That's... Oh, dear. I mean, that's actually quite good for you, actually. It wasn't bad.
I can give you another one if you want.
No. Let's stop there. Let's move on with the show. I mean, before we actually do discuss the topic that we're going to cover today, I wanted to just remind our audience, our listeners and viewers out there, to comment on any of the shows on whatever platform you happen to be on, because we do listen to your points of view and we do take it on board, especially if you want us to cover particular topics, revisit them, or anything new that you think that we should discuss. So please keep any comments and feedback coming in. We do look out for that. Right, let's move on with the topic for today. And today we're going to discuss the Big Bang. Was there anything before it, or was it what it is, the Big Bang? That's where the universe started. Tyre,
Yeah.
Do you want to kick things off?
Okay, well, obviously, neither one of us are trained cosmologists, which is probably a good thing, because in my opinion, most trained cosmologists are, well, how can I put it politely? I don't think I can, to be honest, but...
Why? What's your gripe about cosmologists?
They come with... They approach the subject with an initial bias. This is the problem. They are determined to not see the hand of God, if you like. So they do everything in their power. They bend over backwards to avoid special creation, if you like. So it's like, no, there must not be anything like that. Now, for a long time, I was not a creationist. For a long time, I was of the opinion that I actually thought for quite a while that the universe had always been there, because I didn't understand the ramifications of saying that. So I thought that there was something behind the universe, some kind of intelligence, if you like, an eminent, is that the word I'm looking for? Yes, I think. Universe, imminent. I'll have to look that up. Okay. One that a pervasive one that was everywhere, and oversaw everything, or intelligences. I was happy with that, but I didn't know if the universe was created or not, and it didn't bother me. So I could live with the standard cosmology. It didn't disturb me. But the more I learned about what it is actually entailed, the more obvious it is that it's a load of... I don't want you to spend all your time bleeping out my my words, so I'll contain myself.
Okay, good.
But basically, it's BOLLOCKS. It's a load of that. It's nonsense, and it's like, why are you? The only reason that you're spewing this stuff is because you've got daddy issues, with the God thing. And the funny thing is that you don't even have to go to the God thing. The alternative could be, as I am, I don't know. Why don't we just say we don't know, which we don't know? Why do we have to provide an answer? We've had this discussion before when we're talking about evolution. It's like, why must you provide? If you don't know, you don't know. But you keep studying, you keep researching, and then one day, hopefully, you will find out.
Okay, but you seem to have added in there the
Mhm.
God thing, like it was created by some omnipotent divine being, but there's no evidence for that either.
No, it's
And
just that it's
so,
more logically consistent. As
more
as
logically
opposed to
consistent that a omnipotent being controlled and set up
no,
everything. That doesn't
yeah,
sound.
yeah. If you go through that route, then yes. But if you say, look, the way you just talk about an omnipotent being and stuff like that, this is where you get into problems. Why don't you just say the cause of the universe lies outside of space and time? It's an intelligence is intelligence and it lies outside space and time because that's where information came from. If you put it like that, finish. You're not restricting yourself to a being or a man or a bearded fellow up in the sky in robes and things. It's like you don't even know what you're talking about because it's beyond our ken. It's beyond our ability to comprehend. But we know that it can't be in space and time because it's outside of those things. It has to have been outside of those things, and it had to be intelligent because it's provided information. So,
Why? Okay, but
but and anyway, but the Big Bang, thinking that the Big Bang has got something to do with where the universe came from, is a common misconception. The Big Bang actually, the standard theory the standard Big Bang theory doesn't deal with where the universe came from. It deals with how the universe started. And I think all the cosmologists will be very happy that I've said that, and they'll be like, okay, at least he knows a little bit of what he's talking about.
so it's just where it started,
How it started.
how it started,
Yes.
but the blackness of the universe before that was just there.
No, there was no blackness in the universe because apart from this singularity, apart from this very small point, which was, don't ask me how they know, but I don't know. It was 10 to the minus 60, 10 to the power of minus 60 meters wide.
Okay.
Everything was crammed into this 10 to the minus 60-meter wide speck. It's tinier than a speck. It's tinier than, I think, I don't know what an angstrom is, but I think it's smaller than that by loads. So it's infinitely small.
Mm-hmm.
It's incomprehensibly small. And it was like that for 10 to the power minus 49 seconds
Mm-hmm.
when it expanded to 1 meter during what they call the inflation period.
Yeah.
All right. So we're going to get into all that later, but they're starting with this thing that was this singularity, and that's the starting point of the Big Bang. So where it came from, how it formed, all that's beyond the standard Big Bang theory, and it's a mistake that sometimes people say that the Big Bang theory is that suddenly nothing exploded. No, that's not. It's funny. It's funny. It sounds funny, but it's inaccurate.
So if you were a scientific person, you would look at what you see currently in the universe.
Mm-hmm.
You can measure the distances that these things are moving around us and away from us.
Mm-hmm.
So when you do the calculations and you reverse that, it all basically boils down to a single point. And that's how the maths and the physical measurements seem to imply. So if all this mass in the universe, which they can see, they work backwards, and where it's traveled from, you have a single point, and that's where they get the Big Bang from. Because if this accumulation of mass, you draw it back to its origin, it goes back to that single point, and that's where you get the singularity. But even science doesn't say that how it started. It just, that's what it looks like. The Big Bang occurred, so to speak. But what was happening before then, they don't know. There's been theories about it, but they don't know the start of the universe. I don't think they've said that. It was the start of all the matter in the universe, the Big Bang, but it didn't actually create the fabric that this matter lives in. They don't know how that was there. And there's various theories about it.
It's you're not too far away from it. Now, I'm going to be reading quite a lot of this during this particular episode because I can't remember all the stuff out of my head, so I've had to write it all down. And I've tried to tell a story so that non-science people, people with even less science than me, will understand it. And to go back, we have to go back to an early model of the universe, because I'm going to try to show that what you've said is fundamentally incorrect. It is the standard. You've more or less stated the standard cosmology, the accepted cosmology by the greater number of scientists right now. And I'm going to try to show during this episode that it's incorrect. So, in order to do that, let's go back to the early models of the universe. The early model of the universe put the Earth at the center.
Yeah.
And everything else went around the Earth. It was called the geocentric model, right?
Because that made out that humans were important in the scale of things.
Humans were important in the scale of things because God created the gods, obviously. Because I mean, the geocentric model started out with very ancient civilizations, way before even Christianity and all that. So the gods created the universe. Man is very important. Everything, man is at the center of everything. The sun and the moon went around the Earth. The stars went around the Earth. Everything went around the Earth. But the model, as we learn more and more about the universe, I think the geocentric model held sway until surprisingly recently. Talking about the 16th century, for goodness sakes. So what's that, 400 or 500 years ago?
Galileo, wasn't it?
Sorry?
Galileo?
Galileo, yes. Copernicus.
Copernicus, that was it. Galileo reinforced it.
Yeah, he reinforced it. And obviously Copernicus didn't want any trouble with the church. Was like, okay, if you don't like what I'm saying, don't burn me at the stake, man. Forget about it. Galileo came along and he reinforced it, as you've rightly said. Now, the problem, they actually created a very beautiful, very intricate astrolabes. You know what an astrolabe is? You turn it and it shows the motion of the planets and things like that. And they were able to account for everything, but they did it by adding more and more variables, more and more what we would call a variable, and it became highly complicated. But it's also achieved one remarkable side effect, which was that it could explain anything. If you had an asteroid come out of nowhere and disappear, it could explain that. So there was nothing that it couldn't explain. Now, there's a problem with that because it means you can't falsify the model. Doesn't matter what you say, it'll be handled by the model. Do you see?
Okay.
That's not how it works in real life. In real life, we can falsify, not in real life. What I mean is with a scientific truism, we can falsify it. Like if we say all sheep are white, You can falsify it by showing a black sheep,
Okay.
right? But if you say all, I don't know, all sheep are white except for the ones that aren't, that you're not saying anything. You haven't said anything, because what do you mean? It doesn't mean anything. So this model was kind of useless in the end, because it could handle anything: black sheep, white sheep, sheep with 5 legs, whatever. It could handle it, and people realized that it was a failed model. I've actually got to pause for a second. Is that okay?
Oh, okay. We'll pause.
Sorry. So what was I saying? What was I talking about just now? Sorry.
The model that you said was covered
Right.
everything.
So yeah, it could it could handle everything, and that was useless and not fit for purpose. And the reason I just bring it up is just this idea that
Can you just clarify something? If it worked, why was it not fit for purpose? You're contradicting
because it
yourself.
could handle anything, because you couldn't falsify it.
So if you couldn't falsify it, why did they not keep that model? That means it's proving
No,
a
because you can
working
prove
model.
anything. You can prove nonsense. You can prove something that is clearly incorrect. You can prove that the moon came out of the earth, or you can prove that the earth is smaller than it. And you can't really, but
Right. Okay. So
anything that you said would you could work it out. It'll be fine.
Okay.
That's not a theory. That's a theory that just allows anything to happen. So, like I was saying, if you say that you have white sheep or any other kind of sheep, you haven't said anything.
Okay.
Do you follow what I'm saying?
I sort of follow it, yeah. But go on.
All right. So, well, anyway, the idea is, I'm trying to introduce this idea that if you've got a mathematical formula, but you plug in variables into that formula, and it can account for things by adding more and more variables into it, you don't really have a theory. That's the I'm trying to lay that foundation now. That we've tried this before with the early geocentric model, and we failed. It failed because it could handle anything by introducing more and more complexity. Okay.
Okay.
All right. Now you've got that. Put that to one side. So back to our Big Bang. Do you know what a black hole is?
Yes.
Would you share it with us?
A black hole is where a star has collapsed on itself, and the gravity is so vast that not even light can pull away from it. So everything that comes towards it is sucked into oblivion effectively, because the gravitational force is so great that, like I said, not even light can escape it.
Right, exactly. It is an object that is so heavy, it's so massive, it's got so much mass, but that mass is held in such a small space that the gravity actually overcomes even photons of light that are trying to escape it. Nothing can escape. It warps space-time to the point where nothing can leave that gravity field.
Okay.
Right?
Yep.
So can you see a problem here? If everything in the universe was contained in a tiny point, that was be a black hole. In that case, how did anything escape the black hole?
That's a good question, but there is some evidence to show that even now, black holes do leave trails of matter behind it, because black holes are not stationary. Black holes move with their respective galaxies, because black holes so far have been discovered in center of galaxies, and galaxies are not stationary. They move as well. And they've discovered only recently that as the black hole moves, it leaves some residue behind, which goes on to form new stars. So yes, the black hole is super dense and not light can escape from it. And when you get to the event horizon, which is the bit where you're literally dragged into it, that bit then means that you're going to be crushed. Whatever it is you are, light, matter, you name it, is crushed. And you're right. And a single black hole is tiny in comparison to all the matter in the universe if it was in one space. But the point is that Big Bang, that explosion was not, that's what started it all off. You're right. It was a small, super dense, maybe. Was there even gravity? It must have been. If you think about it, if all...
Yeah, I mean, I'm just laughing at your term. This wasn't super dense. This was mind-bogglingly dense. This was
exactly.
Everything.
But this was before matter was even in matter form. Because if you remember, the explanation seems to be that hydrogen hadn't even been created or come together, because it was so hot that there was no matter. It behaved in a way that doesn't correspond to what we see now. So the way that black holes work now is because the universe has cooled. This was at a point where whatever caused this explosion at the Big Bang stage was so vast that caused this inflation so quick that it was, I suppose that's why it's a Big Bang. It was unprecedented. I mean, science is not saying that that is the definitive answer, because if you understand it, the Big Bang is a theory. It's not a fact.
Don't get sidetracked now.
Well, it is, though.
No, don't get sidetracked with that.
Okay.
So, E is equal to mc squared.
Okay.
Yes, you didn't have protons and electrons and things like that.
You had nothing,
the atoms. But you did have energy.
Yep.
Right? And energy is mass.
Okay.
All right, so you still had the mass. So the argument that you didn't have those protons and things doesn't hold water, because we also believe that in a black hole you don't have atoms and things. I mean, squashed out of existence.
Okay, possibly. So, I don't know much about what happens to the matter once it's in the black hole. That's still a mystery anyway.
The speculation is that even that the nature of matter is completely different.
Well, we don't know that either.
No, I'm talking about, this is the mathematics now. Okay. It's the math. It's what the standard cosmologists claim. I'm repeating what they claim.
Okay.
All right. So that for me is a big what's going on here. Why did anything escape from what has been the greatest, densest, most astonishingly black of black holes? Now, you spoke about matter leaving trails of matter behind. If a black hole passes and you don't enter the event horizon, but you are close to the event horizon, then it can perform odd things upon you, obviously because of the gravity.
Yeah.
It will shatter planets and things like that. And if you're not within the event horizon, there's no good reason for you to not still be there after it is passed. You won't be in the same form that you were as before it showed up. So saying that a black hole leaves matter behind isn't saying anything. It's not contradicting what I'm talking about. It's got nothing to do with it.
But what I'm finding strange is that you're taking the scientists' view of what a black hole is and you're cherry picking. So you'll take that as, okay, cosmologists say that's how a black hole operates, and you'll take that as fact. But when they talk about the Big Bang, because it contradicts some other system that you believe the universe has created, you don't take that. So you're cherry picking what you're taking from the cosmologists, because the cosmologists are only speculating about the black hole. We've never seen one. We've only done it through the mathematics. We've sort of depicted one because based on the calculations, so there are images of them, but we don't really know them either. And the same with the Big Bang. We don't know fully whether the Big Bang is right or wrong. No scientist has said hand on heart, it is that. It's just the maths seem to lead to that. And yes, it still asks further questions, but it's not like it's the one that seems to be the most, not believable, the one that's the most correct in as far as they're concerned. They don't have the full picture either, but it's the closest one they've got.
No, you're incorrect. This is the standard cosmology. When I say this is the standard cosmology, this is the stuff that's been taught in universities today. If you don't write this stuff down, if you don't support the black hole, the Big Bang theory, you'll be on a very short shrift with.
I'm not sure about that. That's
there's a poor chap called, well, he's dead now. ARN, I believe his name, Dr. Arn, or whatever his name was. Okay. When he started throwing up a fuss about the Big Bang theory, he actually found it very difficult to get onto telescopes, to get telescope time. He was being actually held out, and he wrote about it. And if you give me I'll write it down. Dr. ARN, I believe his name is Dr. R. We'll circle back, and I'll give you the name of the book where he talks about his trials and travails. It's like poor old Dr. Mary Spitzer, who found hemoglobin in dinosaur things, and then she's been having a lot of trouble since then with the scientific community. It's not kind, because you're messing with people's grants, man. You know. So anyway, I'll try. I've written it down. I'll try and circle back, and I'll give the book where he discusses the problems he ran into just because he was questioning the Big Bang theory. It is conventional wisdom now. That's number one. Number two, you said something about I'm cherry picking. I'm not cherry picking. I'm not the one who said this is how a black hole behaves. It's the standard cosmology. Nothing can escape a black hole. That's what Stephen Hawking and people like that said. So all I'm saying is, as a question I'm asking, I'm saying, well, hang on, wouldn't this early inflation? Wouldn't this early pre-inflation? What's the word I used again before earlier? What's that?
Inflation.
Yeah, no. Inflation. Yeah, inflation. Isn't one of the pre-inflation tiny speck, that 10 to the power minus 60 meter speck? Wouldn't that have been a black hole? And if it was the black hole, how did it let matter out? So I'm asking the question that's an inconsistency. It's not consistent.
Okay. You said, I mean, funny you should say that about black hole. There is actually an alternative to the Big Bang theory called the black hole theory. Mm-hmm. Did you know about this? Yeah. And the black hole theory actually says that our universe is located inside a black hole that exists in another universe. So in this model, our universe was created when a star in another universe collapsed into a black hole. So our whole universe is in a black hole. We are in a black hole.
You came from a black hole, I can understand. In a black hole,
we're in a black hole that exists in another universe.
We're in a black hole. Why aren't we crushed?
Because the crushing bit only happens when you come through the event horizon.
All right, so we were crushed and we came in through the event horizon.
No, a star came into the black hole, was crushed, and that is what caused the banging and the splitting. And because the black hole is like a doorway through universes, in between there's like the black hole itself.
Well, gateway, something.
Yes, as a star came in, it created that explosion, which then created our universe, but we are still within the realm of the black hole.
I don't know why we have to be within. Theory. I don't know why you need to emphasize that. That's one point that just doesn't really make any sense, that we're still within this thing. And it's a different universe, and we're in a separate universe, and yet you're saying that we're within this other thing.
We've come through the other side. That's what's
so we're no longer within then, are we?
Okay, well, the black hole started it all. but it was only a gateway through a different universe.
I haven't heard it to that degree of fidelity that you've shared with us, but it does sound pretty outlandish.
Well, why does that sound outlandish? That could emphasize where the Big Bang came from. It was actually a collapsed star in the black hole.
Yeah,
and that's how our universe began.
No, because in a certain way, what you've done there is you have created a steady state, infinitely old universe.
Yeah.
And there's a problem with that. And the problem being that if the universe or universes are infinitely old, it should all have run down by now.
Why should it?
Well, because of the second law of thermodynamics, we just eventually everything just runs down. And if it's been around forever and ever and ever and ever, where's all this new energy coming from? There wouldn't be. All these multiple universes would all be dead because they've been around forever. But our universe can't have been around forever.
It's been around for 14.5 billion years from when.
If you swallow the bile that is what we're talking about, then yeah. But there's good reason to not believe that, as I'm going to show.
Why is that a problem? The time frame.
Go on. I've got a lot of things to talk about. So
Can I give you the alternative universe theories as well? The start of the universe. Okay. Yeah. You mentioned the steady state theory. So some of our listeners are probably wondering, what the heck are they on about? What is that? This is the theory that suggests that the universe has no beginning or end and is continually expanding whilst maintaining the same overall density. And in this model, galaxies, planets, and other forms of matter are locked in a continual recreation. So they break down, recreate. And since the density remains the same, all the astronomical objects become unobservable and as new creations take place. So they break down, die, and then recreate. So it's the same density in the same universe, but it just keeps going round and round in circles. So it's been around forever, no beginning, no end. It's just the matter within it that just keeps breaking and recreating. It doesn't disintegrate, it's still matter. The other one, another one, which is an alternative to the Big Bang. So you said that the Big Bang is the commonest one, yes, but these are also alternatives that are also discussed amongst cosmologists. So they're not all poo-pooed, if that was your language. The other one was bouncing cosmology. Now, this one suggests that the universe undergoes a never-ending cycle of expansion and contraction. So in this model, the universe expands from the singularity, which is Big Bang, reaches a maximum size. It grows and grows and grows, gets to a maximum size, whatever that is, and then it contracts slowly back again, back into a big crunch, crunches back in, and then starts again, and then repeats. And this continual bouncing cosmology over billions and billions and billions of years is how the universe exists at the moment. And something that is equal to that, similar, because that's called bouncing cosmology, one that's called the cyclic model, that is very linked to bouncing cosmology, where this suggests that the universe undergoes an infinite number of cycles. Then, so it's not inflation and inflation and crunching. Inflation and so a bang occurs. What the cyclic model says, it's expands, reaches a size, contracts, and then starts the cycle again. So it is doing it in a similar manner, but it doesn't have to wait for a crunch. It just gets to a point and then it just almost springs out again, which again, there's no evidence for that. The other theory is eternal inflation. So basically that once we've had that start, the universe will continually expand forever. And then we will eventually never see any other stars and galaxies because it would have spread for infinite and everything would be so far away from one another. Like an explosion. You could, if you could mimic the Big Bang like an explosion of a firework, that's exactly what happens. There's a bang, it explodes out, you get all the flame, all the color at the beginning, and it spreads out and then slowly peters out as it's getting to the far reaches of the energy level, and then they're so far apart from each other, the energy's waned and disappeared. So that's another one. The black hole theory, as I've already explained, that seems to be the next best one, actually, because that gives an answer as to how it started and where it started from. Because most of these theories, the Big Bang is the Big Bang. It started with this intense bang, as you've rightly said, 10 to the minus 60 in terms of size. It's tiny. And then it had all the mass in the universe from it. But the black hole theory suggests that this mass has actually come from a subsequent universe next to ours. And it's just created this bang in this universe. And it is just one of a multiverse of universes. That seems to be the most credible alternative in my mind. Or the one you love the most, Tayo. The other one is we're just a simulation. But we can touch on that one a little bit more, because I bet some of our listeners would be intrigued on that one, whether we are actually really here, or is this all a mere simulation by some higher intelligence? I don't know. What's your view of these alternative to the Big Bang? Any in there? You're on mute, by the way. Any in there that take your fancy?
No, let me just quickly destroy them. Maintaining the same density. You can't maintain the same density if the thing is expanding.
Not density. You see, the overall density of the material in the universe is the same. It's not changing. The matter, the energy.
You mean the amount? You mean the mass?
Yeah, the amount.
Total
the
mass.
mass. Yeah.
You said density.
Sorry.
So, okay. So we misunderstood that. Yes, steady density. Mass.
Steady state theory.
Constant mass is not a problem. I don't see that as being a problem. I'm not going to come back there. No, the Academy of Sciences is they're the arbiters of what is science. So we have an Academy of Sciences. I don't know what it's called. The Royal Society for Science. That's what we've got. In America, they've got the Academy of Sciences. Countries have got these bodies. These bodies are the acknowledged arbiters of what is science and what isn't. So worldwide, all academies worldwide kowtow to the Big Bang theory. They don't kowtow to any. There's no other theory out there that holds sway. It is the standard cosmology. That's what, as I said, that's what you have to regurgitate when you're taking these courses at uni. Anything else will get you a fail.
Yeah, but that doesn't mean that is fact. It's the best theory they have to explain the origin of the universe. It doesn't mean it's unchallengeable.
No, it's not unchallengeable. I never said it was. All I'm saying is, because you said something, I wrote down here, Academy of Sciences. I think you were trying to say that there are these other theories out there. And there are people who've tried. This Dr. Arn, A-R-N, he tried, but a lot of the predictions that he made have now been actually refuted. They've been debunked. So his is a failed cosmology. There were two other people whose names I forget now.
And what was he proposing? What was his theory?
Well, he was against the
Big Bang.
Stood against the Big Bang, and I believe, if I remember properly, that he was basically proposing a steady state.
Okay.
Steady state universe. Now, but rather than propose, and he did propose something, but his main arguments were against the redshift, which I'm going to deal with. Okay. So if people don't know what the redshift is, I'm going to come back to that as quickly.
I'm mindful of the time here. We're actually moving on quite a bit.
15 points, and I haven't just done the first one. Eternal inflation.
Yeah.
But that's basically the Big Bang. That's what we're saying is happening now. The universe is spreading out in all directions. And because of the second law of thermodynamics, that works very well. Eventually, what will happen is that we'll just run out of energy. The
Yeah.
universe will become a cold, dead universe.
Mhm.
Now, this cyclical universe, yeah, the problem with that is nobody knows where the gravity is going to come from to do that. Because, yes, we're expanding. So, what's going to slow us down? We need gravity to do that. And there isn't enough matter in the universe to slow us
To
down.
slow us down.
So there's no gravity for that. So that's been poo-pooed a long time ago. And that's why I said it was very easy to poo-poo that. And then this black hole theory of yours, you actually mentioned what I was written down here. You've mentioned it yourself. That's the multiverse theory. But the multiverse theory fails because all you're doing is pushing back the question of origins. That's what you're doing. It's like, okay, that universe came from another black hole.
But
and that universe came from another black hole.
Yeah, but
the
isn't
problem
isn't that
this,
what you're saying about an intelligent being outside of space and time? You're pushing it out to something else.
These other universes are also in their own space and time.
Yeah.
This thing we're talking about is not in space and time at all.
But you've got no evidence for that either. That's because we've reached the end of our level of understanding, and a quick win is to say, oh, it must be some intelligence.
No, we know there's logic, isn't it?
Is it logic?
Yeah, it's logic. It's that if there is intelligence in the world, in the universe, and the universe itself doesn't produce intelligence, we've never seen it happen. Ergo, the intelligence came from somewhere else. I mean, that's just logic.
That's not logic at all.
What do you mean?
That isn't logic at all, is it?
If you smell a fart on the left,
it
came from somewhere. All right, somewhere dropped one. There's no if when. It's logic. There's no out of it. All right. It's not a miracle lift. There's something. What the hell is that? Someone was in there. You didn't see the guy. You can't, but you can surmise. Anyway, like I said, that's what. And then simulation theory. We'll get to simulation theory
if we get time. Okay.
So anyway, this black hole thing that I was talking about, and you spoke about this, that when is this tiny point, it expands. Well, there's another problem with that. You see, scientists will tell you that the small point, that infinitely small point, was expanding into nothing. Okay? Because as it expanded, the universe was creating space and time.
Space
right? It was actually creating more and more space. So it wasn't expanding into something because there was nothing to expand into. And then I come and I say, hang on. My objection to that is this. If nothingness doesn't have a property that can accept something because it's not there. Do you understand?
Mm-hmm.
It's not there. How can you put a there into not there? It's not there to put a there into. In the back of your head, in the minds of these people, they are making a very subtle logical error in that they're imagining that you can put something into, because in their minds they are still envisaging space. But there is no space. There's nothing. You can't go there. It's not there.
See, that spooks me out in a bit, actually, if you think about it, where what is nothing? And there's places in space where there is nothing.
No,
literally nothing.
There's space and time. There's space-time. There's nowhere in our observable universe where there's nothing. There's always space-time. That's the problem. That's what these people are imagining. They're imagining sort of a darkness, a nothingness. But it's not nothing, but true nothing, it doesn't have that. It doesn't even have nothing. Because then it wouldn't be nothing. It's basically, like I said, it's not there.
So what are you saying, going back to this theory, because
you can't expand into
my brain has just gone boof like that there now.
You can't expand
and most of our listeners
into
probably.
That's what I'm saying. You can't expand into something that isn't there because it's not there.
Not there. But can you create something, which is what it was doing?
You can create something, but you can't expand it into what is not there.
So you're saying then that the universe has existed before the Big Bang?
No, I'm saying the Big Bang's a little bollocks is what I'm saying. That's what I'm saying.
Oh dear. Let me
Then
make a
look,
note of
and by
that.
the way,
43 minutes.
sorry, what?
I've got to take your swearing out.
Oh, sorry. Okay, it's a lot of nonsense.
Yeah.
Um,
We're
and
getting a
okay,
lot of
so
we're getting a lot
why
of
do
younger
scientists
listeners, so that's why.
why do scientists believe in and trust the Big Bang theory? Okay, they do it because the Big Bang theory made one prediction, which was spectacularly confirmed in the, I believe it was the 60s. I
What you
might be
mean
wrong.
about the red shift and blue shift?
No, about the cosmic microwave
Oh
background.
yeah, cosmic microwave background radiation.
Correct. And because this is what science loves. Science loves it. If you say, oh, look, if blah, blah, blah is true, there must be X, Y, Z out there. Just like when Newton's theory of gravity was confirmed because somebody noticed that planets were wobbly at the edge of our solar system. And he did the mathematics and came back and said, there must be a planet out there. And then yonks later, we found Pluto.
Yeah.
That's what science loves. That they say, predictability is everything in science. So because of the CMB, the science. This is what has made the scientists go, okay, it's the remnants of the Big Bang, and it's exactly what we thought. Well, more or less exactly-ish, what we thought it would be. It was predicted by the Big Bang. It's with gravitational waves and everything. That's it. It's cool, okay? So if I know that, why am I not then a Big Bang proponent?
Okay.
Excellent, okay.
So why aren't you?
Because that is a win. That CMB is an undoubted win for the Big Bang.
CMBR, but yeah, go on.
Okay, it's an undoubted win for there's not a hate more than a pedant or pedants. It's a big win for the Big Bang Theory. However, there are problems that just insurmountable. One of which, for instance, is that when we look back into the farthest, what we think of, according to the theory, are the farthest reaches of the universe.
Yeah.
So we're looking back into the ancient time, into very close, just a few 100 million years after the Big Bang.
Yeah.
What do we see? Fully formed galaxies.
Well, that's only recent, isn't it? That's why
the point is that we do see them, and we're asking, why should they be fully formed? How could they have formed fully in just a few 100 million years?
Impossible.
It's impossible.
Well,
so it isn't reasonable. And for me, straight away, this is where reasonable people just go, the theory is wrong. Because
could it not just be that the theory of how galaxies are formed is wrong rather than the Big Bang? Because it's the galaxies that have been discovered early doors, and it's like, well, maybe the galaxies are formed far earlier and quicker than we realized. So it could be the formation of the galaxies that's up in doubt rather than the Big Bang.
Well, there's no reason. I mean, sorry, you said something earlier. Oh, God, I didn't write it down. You said something earlier. Oh, okay, I'll have to let it go because it relates to what you've just said. To what you've just said now.
What? The recent discovery
about seeing news about seeing in the wake of black holes where they've passed, that we're seeing new stars being formed and stuff.
Yeah.
No, we're not, because we've never seen anything new. That's one of the problems from my studies of evolution and things like that. That is why I'm anti old universe. One of the reasons is we've never seen anything form. There's a one case of a questionable case of a nebula, but there are all sorts of ifs, whens, buts, and howsoever's. And
yeah, but if you think about the time frame that we humans have been around, then we're looking back at certain points in time, but we're not seeing everything that's happened in between that time. So we've only got a small window to look at. So making that claim just because we haven't seen it doesn't mean it doesn't happen. Seems a bit odd.
Well, it's just like we said before that if you predict the CMB-R,
Yeah.
and nobody, I don't think
Cosmic
anybody
microwave
apart from
background
Tony,
radiation. Yeah, go on.
okay, everywhere I've read it's been CMB, but okay, CMB-R. If you make that prediction and then you find it, you can take that. But then again, when we make a prediction that we're going to find galaxies that look like this and they don't, well, that's a problem, right? So,
Right.
and I think it's such a big problem that this is where I just go that that's a showstopper. However, if you don't like that, do you know about Edwin Hubble?
Yep.
Did you tell who is and why the redshift thing?
He was the one that worked out, he worked out that when things are moving away from us, there's a red shift in the light that produces. And when they're coming towards us, there's a blue shift in the light. So you can actually tell, by and large, where things are. If the universe, in the universe, galaxies are either moving away from us or coming towards us. But when you look inside a galaxy itself, you will notice both. You will see blue and red shift because the galaxy's turning around, isn't it? Some of them is coming towards us while others is moving away. But if you look at the galaxy as a whole, it was red shifting, so it's moving away. And that's how they worked out that a lot of the galaxies are moving away from us as opposed to coming towards us. If you look inside individual galaxies, you will see blue shifted light as well as redshift light because the galaxies are turning. And as they turn, the lights and the stars within that galaxy are actually heading towards us. So those are blue shifting. But as they go around, effectively, they turn to red and because they're going the other way. But if you look at the galaxy as a whole, it's red. The whole thing is shifting away. That's how he devised this.
Very good explanation. For our lay people out there, if you put a prism in front of a light source, a white light source, you'll see that you get colors of the rainbow coming out on the other side.
Yeah.
And that's how light is split in the prism into its constituent wavelengths, if you like.
Yeah.
And it goes from red all the way up. I don't know what the exact order. Roig red, orange, yellow, green, so something up to violet.
Yeah.
On one. So the sections, if you like, the sections of light can either be evenly split or they can have gaps, can't they, in between them? And these gaps can form and squeeze the bands or expand the bands. So a red shift is when red has shifted more towards one side than the other. That's your red shift. That's the shift we're talking about. And the blue shift is the when blue has shifted away from where it would normally sit. So if it's shifted like this, you got a blue shift. If
For our listeners here who aren't seeing Tayo moving his hands, he's drawing he's drawing things in the air, but he's showing how the blue shift is shifted over to the left and the red shift is shifted over to the right. In rough terms.
In rough terms, that's what happens. So it's like this, like so that everybody can hear this. It's like it's the Doppler effect because it's like this. It's like a sound. Everyone, I hope, has heard a siren or a train or a car, a motor car, anything that's passing is coming up towards you, and it goes like this. That change in pitch is the Doppler effect, and that's for sound. And the redshift is a Doppler effect for light.
Yeah.
So when an object is moving away from you, you're seeing the equivalent of a only you're seeing it instead of hearing it.
Yeah, and it's red.
And it's red. And when it's moving towards you, it's growing. That's the blue shift. and you're seeing that. So that's what the redshift and the blue shift are. Now, the chap who found out was a very clever gentleman, and if this is about 929 or something,
It
926,
was
929.
early, wasn't it? Yeah.
Yeah, and his name was Edwin Hubble,
Yeah.
and he proposed, and he said, look, that the redshift can indicate how far away we are from an object. And he proposed the idea that actually there's this Doppler effect thing, that actually these objects are moving away from us or moving towards us. If it was red shift moving away, if it's blue shift moving towards us. But but before he died, he changed his mind. And people don't normally know that, realize that. And he said this, as reported by the Associated Press, quote, "The universe probably is not exploding, but is a quiet, peaceful place and possibly just about infinite in size," end quote. And if you look for Hubble, no evidence of Big Bang Theory online, Hubble, no evidence of Big Bang Theory online, you will find that quote from the Associated Press he made before he died. And interestingly, there is one thing that I would have thought would make secular scientists very worried about redshift, and it is this: everywhere that we look from planet Earth, right, we see uniform redshift. The patterns appear uniform. And if you think about it, if everything's moving away from us, what does that mean where we are?
Well, that's implying that everything is moving away from a big bang that we produce, so it's moving away from us.
It's moving away from us. So where are we?
We're not in the center of the universe, if that's the theory that you're alluding to.
That's when we consider the quantization of galactic redshift. You see, redshift happens in clumps, it seems. It seems that it's about the spacing of redshifts. Redshift happens like every 2 million light years or so. And that's the quantum. That you remember, like if you know anything about nuclear physics, or I think particle physics, you know that electrons go around the nucleus. I'm waving my hands around again. in certain orbits. They don't do 1.5 orbits. They're either in orbit 1 or they're in orbit 2.
Yeah.
Or they're in orbit 3. Those are the quanta. There's nothing in between. You're in 1 or you're in 2, right?
Mm-hmm.
Well, this is why it's called quantized redshift. That we don't see 2.5 million or 2.6 million or whatever it is. We see 2 and we see 4, and so we've got this quanta as if it's concentric circles. And the thing about it is that if we look at if we think to ourselves that we're looking at a universe, we should not see this regularity of patterns. We should see differences between looking this way and looking that way. But if we look all over no matter where you are, Australia, China, Europe, Africa, wherever you are, America, wherever you are, wherever you look out, you're going to see the same quantized redshift. Then the conclusion is that we are very close to what must be the center of the universe. In fact, according to this thing I came across, instead, our observations show us to be within 100,000 light years from the center of the universe, which, in the context of the entire universe, is so astronomically precise to a degree of such improbability that we might as well stick a flag in the ground and declare God did it, because it's just too unbelievably precise. So there is that. However, as I say, Hubble himself didn't think that redshift meant receding universe. No. And I'm not sure myself that it does, but I don't have the mathematics to prove it, so I have to shut up.
So was he a steady state theory person? So he thought that the universe had no beginning and end. Just continually expanding.
The universe must have had a beginning and end, because an infinitely old universe would be dead because of the second law of thermodynamics. There's no way out. There's no way out. We cannot be infinitely old. It's just that, and in fact, even multiverses can't be infinitely old. That's the problem in the multiverse theory. It can't be that way.
That's you're now saying can't in a statement that we don't know very much about. I'm mindful of the time, by the way, because we're actually getting close to the top of the hour. We've got
about
so
magnetic
much.
monopoles yet.
We may have to
the
wrap up
flatness
soon.
problems.
Yeah.
Or well, I've already mentioned the second law of thermodynamics, but the other way that I'll just
Go on.
since you're mindful of the end, I'll just look. This is the other thing that should make everybody wonder. The Big Bang makes a monkey of the second law of thermodynamics. The second law states that matter has an inherent tendency to move towards randomness. We've all seen it. It's the reason why buildings left to themselves fall into ruin.
Okay.
It's the reason why, flasks of liquid, the temperature, it eventually evens out to its surroundings.
Entropy, where everything breaks down. That's the word. It breaks down. It doesn't become...
But the Big Bang is the exact opposite. The Big Bang is from maximum entropy, you're moving towards less entropy. Things are becoming more and more ordered over a period of time.
Well, heat can do that, though. Heat can certainly do that. Because when things cool down, things clump together. There's evidence of that even now. So you can't actually throw that out the window. Because when things are extremely hot, they can't bind to one another. But as they cool down, they do. Because maybe gravity doesn't play a part at those extreme levels of heat. There's something that's we're not quite clear about. And gravity and magnetism maybe doesn't work at these super high temperatures. That could be a factor. That could be a part of science that we still don't know too much about. But as things cool down, then magnetism and gravity start to manifest and actually do their stuff. So this theory that you're saying that is all a load of rubbish may not be the case. It's just because we're still finding out, and this is the best theory that we've got to sort of explain the maths. But you're right, even science admit it may not be right because it's a theory, but it's the best one so far. They're not poo-pooing the other ones, but there's not a lot of evidence to back them up. Personally speaking, I think the black hole theory is the one that excites me the most, because that seems to give a beginning to the Big Bang. It makes it more plausible. That's just my personal view.
The idea that cooling down and clumps into more orderly states of matter. Well, I challenge you to take a bomb into a junkyard, detonate it, and then expect more orderly.
Well, no, elements. But that's you're talking entropy again. Now you're talking about.
Well, you just said that you're expecting. You've just finished saying that you're expecting order from this explosion because it's cooling down. I'm trying to show you that.
Well, you're telling me that the bits that say, there is clumping together. That happens. That actually happens.
Yeah, but it doesn't clump into something that's orderly. I don't know.
We're not saying that the universe is orderly either. We're saying it clumps together. That doesn't mean it doesn't do it.
Because you have quanta, for instance, like we just talked about quantized mechanisms of subatomic particles. You've got helium and hydrogen, but then you've got the other elements as well. So everything is. I mean, you've got the high elements.
How did the elements start up? The simplest one was hydrogen.
There's a big argument about that.
Hydrogen, then helium, because they banded together and formed helium. There's evidence to show that
would they have banded together to form anything?
But they cooled down. They cooled down enough to attract one another.
Why would they have cooled down?
This is where I'm saying.
Protons.
Right. Magnetism. There is magnetism, isn't there? You've heard of magnetism.
Why would there be magnetism from a random explosion?
But this
Why
is
would
what we're
why
saying.
would there be
We know that
magnetism?
these are fundamentals of the universe. How they got there, we don't know. But they're fundamental elements,
Well, yeah,
not elements, they're
but they're
fundamental
orderly.
forces.
They are
And so
orderly.
when things cool down, they're more easily attracted to one another.
You can't say
Magnetism.
when things cool down, they're more attracted to one another. We don't even know how we got the higher elements. We're still arguing about it. I think iron is the highest element that we think we know how it was weighed, and that's what we think. We don't know how we got anything heavier than iron. You and I are talking. You and I are highly ordered creatures. Well,
Yeah.
one of us is anyway.
I know, but don't put yourself down, Tyler. Come on.
Very good, very good. That holiday did you looking good.
Come on, look, we're reaching the end of the show. You're going to have to sum up here.
I haven't even told you about dark matter and dark energy.
I know.
Why
What we may have to do, we may have to do a subsequent show on
and
this
why they
because
had
we
to be
can't fit
invented.
it all in. Yeah.
Okay.
But anyway, so give us a sum up here on this particular show, what we've
You
discussed.
don't let me use my favorite word. You say you have to beat it up.
Please don't.
Okay. Oh. Well, for those who know me, my favorite word begins with a B and rhymes with rocks. Or locks, basically. Locks. But because Tony sensitivities,
No.
the Big Bang Theory is a lot of nonsense.
Okay. I mean, I'm open to it. I'm always open to it. I'm not a cosmologist, but the bits that I've studied and I've looked at, it seems to make sense with my limited knowledge. But again, even scientists themselves, they're not saying it's a fact. It's a theory, clearly, and there are others in the science community. And that's what's good about science, that if things are challenged and you provide the evidence, then they will change the theory. They will do it. But unless you prove with data, then they're going to stick with the one that sounds the most plausible. So in my opinion, yes, it's debatable with the singularity where this Big Bang. I still have questions about that, but I personally like the black hole theory, which is a slight extension to that, where, as I said earlier in the show, it's where the universe has been, it came with a Big Bang because a star fell into a black hole, and the black hole is the gateway between one universe and another, and that star coming into this black hole that borders our universe created the bang that set off everything that's here that we see today. So that's my personal view. Whether that's baloney, it could be. I'm not a specialist, but there you go. Tayo's nodding his head and agreeing with that. But unfortunately, we may have to revisit the show and cover it again in the other topics that Tayo wanted to mention. But unfortunately, we have reached the end of the show for another week.